So this question says, circle the insoluble compounds and determine the oxidation number for the underlying element. So to give us a little bit more space, I'm actually going to use a highlighter and highlight the insolubles. And I'm just going to do this so that we have a little bit more space. So using the solubility chart, we can just start on the left. So silver chloride, insoluble. Most hydroxide metal compounds are insoluble. So this copper 2 hydroxide, also insoluble. If we look at lead 2 nitrate, all nitrates under all circumstances soluble. So we'll move on. Sodium sulfate, so now we're going to start here. And sodium sulfate, almost everything with sodium is soluble. So that is also soluble. The next one is an iron oxide. Now, on the solubility chart, iron oxides are not in there, so we won't see this one online or on the exam. But using this, many metal oxides are insoluble, so this is also insoluble. Magnesium bromide, soluble. Potassium carbonate. So potassium, when balanced with the carbonate ion, is soluble, and calcium phosphate is insoluble. So we just look at the provided solubility table and figure those out. So now we want to go back, and it also asks us to determine the oxidation number. So I'm going to start with silver chloride. So we know that chloride is a -1, therefore the silver has to be +1. So in this case, whatever is underlined is the mystery. Everything else follows the rules. So for copper hydroxide, so one of the things we can remember is that for copper hydroxide, these have to total up to the negative charge. So it is -1, and there's 2 of them. So therefore the copper is going to be +2. So even though and you could have done this a number of ways to get to the same thing, but we can use the fact that the polyatomics have a charge, and we can go that way. So the same thing will be true for our lead nitrate. If the nitrate is a -1, and there are 2 of them, the lead also has to be +2. So sodium sulfate, we have +1 times 2 and -2 times 4. So this has to be +6 in order to give us a neutral charge. So oxidation numbers, they follow the rules, and we are just solving for one that we don't know. So in iron oxide, the oxygen is -2, and there are 3 of them. So this one is more complicated. So we have -6 on this side. Therefore, the iron has to be +3 because the -6 converts to a +6 and is divided by 2. So for the magnesium bromide, we know the magnesium is a +2. And the bromide ions, there are 2 of them, so they are -1. So if we look over at the potassium carbonate, we have -2 here. We have a +1. So this carbon is going to have to be +4 in order to balance out the +2 from the potassium and the -6 from the oxygen. So now we're going to look at the calcium phosphate ion. Just like we did with lead nitrate, we're going to take the potassium or the phosphate ion out. So we know that Fe2O3 has to add up to -3, and we're just looking for the phosphorus here. So the calcium is not necessarily a part of this. So for the oxygen, we have -2, and there are 4 of them. So we have a total of -8. We need to leave a -3 charge. Therefore, the phosphate has to be +5 because +5 plus -8 leaves the 3 minus charge that we need.